Sir, I'm going to be eating lunch during this live stream. I didn't have any questions get emailed to me, so are there any questions from any of you watching the stream right now? No questions. How odd. Well, if I'm not seeing any questions, I'm just going to get a little bit of work done. Hey Elijah, what's up? This week's discussion board. All right, so let me bring it up. I think this is the one that's just naming alkanes, linear and branched alkanes. Yep. So I'll bring up the discussion board for y'all to see on your end. So in terms of strategies about how to name alkanes, so let's try to think about it in terms of a flow diagram. So first thing we need to ask ourselves is, does it contain a cyclic component? And if it's not, it's linear branched alkane. So this would be the case of 1 and 2 and 4. Then the first thing we need to do is identify the longest carbon first, or longest carbon chain first. So this is honestly the hard part of naming branched alkanes. Let's hope that I've got a dry erase marker somewhere. Apparently I do not still. Okay, so the naming system in organic chemistry is very German in origin. So when you name a compound, first thing you need to do is identify the longest carbon chain if it's something like compounds 1, 2, and 4. And in this case, we count it off. We got 1, 2, 3. Oh, sorry, you can't see that. 1, 2, 3, 4, 5, 6, 7, 8 carbons in this chain. So this would be an octane. Now, next thing you're going to do is write out the different substituents. So let me make this. See if I can do this side by side. So we'll look at compound 1. Oop, can't do it with that. Control N. So I'm going to try to name it above it so you can see the thought process here. So if we look at the first one, the longest carbon chain, 1, 2, 3, 4, 5, 6, 7, 8. The parent chain is going to be octane. The A and E here at the very end tells you that it's an alkane. It doesn't have any double bonds, any triple bonds, no other functional groups other than CH, CH2, CH3, and so forth. Now, before we need to name all the different branches that we find. So we see 1, 2, 3, 4, 5, 6 methyl groups. So this is hexamethyl. And we don't see any other groups on it. So step 1, identify if it's linear or cyclic. If it's linear, identify the longest carbon chain and then name it. And then you want to name all the branches. Now, a mistake students get into is they try to do the numbering first. We're going to do the numbering as a last step. Now, we're going to put a number in for the number. We're going to put a prefix in here to name the number of methyl groups we have. We have 6, so it's hexamethyl. And then we're going to need a number for each of those 1, 2, 3, 4, 5 methyl groups on the chain. So the idea with the numbering is that we pick a starting position on the carbon chain, one end or the other, and we're just going to denote where they are. So how do you know where to start? Well, this is why you want to name the branches first. What we want to do is minimize the numbering. And there's kind of this misunderstanding that shows up on the internet, particularly on Reddit. I watched the organic Reddit thread go back and forth on this. There is an attitude that, well, if we add up the numbers, we want to go for the lowest addition. That's really kind of the wrong way to look at it. Look at where the first group appears. So the first functional group here is a methyl, and we've got a methyl that's 1, 2, 3, 4 carbons away from the end, and a methyl that's 2 carbons away from the end, 1, 2. So we want to minimize the numbering, so let's just pick let's pick the starting carbon that minimizes our first number. So in this case, we've got a 2 for that methyl. and there's 2 methyls on that carbon, so they're both on the second methyl. We've got, that's the 3rd carbon there, 4th carbon, so there's 2 on the 4th carbon, 1, 2, and then we've got 2 on the 5th, 5, 5. So I would call this compound 224455 hexamethyl octane. Now, if I were to go from the other end of the chain, let's say I start from the right side, I would have, let's see, 1, 2, 3, 4. I'd have 4, 4, 5, 5, 7, 7 hexamethyl. So the correct name is the one that minimizes the number at the first position. So if we start on the far right, it starts at a 2. If we start on the far left, it starts at a 4. Now let's look at compound 2. So compound 2, it's a linear chain, and we need to find the longest carbon chain. And this is really where the hard part comes with linear alkanes. So pick one, 1, 2, 3, 4, 5, 6, 7, 8. If I start with this carbon here on the bottom right, 1, 2, 3, 4, 5, 6, 7. Honestly, it doesn't matter which of the ones I start with on the very ends. The longest chain here is 8. So again, the parent chain is octane. So 1, 2, 3, 4, 5, 6, 7, 8. Now, if I look along this chain, I see 2 methyl groups, so this is going to be a dimethyl. And I'm going to need a number for each of those methyl groups. And I've got an ethyl group here too. So I've got CH3, CH2. So we also have an ethyl. And I'm going to need to number its position as well. Now again, this is why I'm saying you really kind of want to start with doing the branch. You want to draw it out first, name the groups that are off the main chain before you try to do the numbering. In terms of numbering the branches, we're going to try to minimize the first number, and if you don't write out what all the branches are, it's a little hard to tell which one comes first. Now in terms of ordering the branches, ethyl, E comes before M, so the ethyl is going to come before the methyl. It doesn't matter that there's a di here. The di is just the prefix for the number. What matters is the naming of the branch. So in ethyl dimethyl, now let's start seeing if there's a way to minimize the number on the ethyl position. So if I start on this far left end, I got 1, 2, 3, 4 carbons. If I start on the far right end, I get 1, 2, 3, 4, 5. So if I want to minimize the number, I would go with the one that would give us the ethyl on the 4th carbon. So if I start on the left, it ends up being 4 ethyl. If I start on the right, it ends up being 5 ethyl. So with that carbon being 4 and that carbon being 1, I have to start counting out the numbers on the branches. So there's a 2 methyl, 3, 4, 5, 6, 7 dimethyl octane. So that's how we would name that compound. And if we reverse the numbering, if we start on the other side, it would be 527 dimethyl octane. The reason we know that this is the correct numbering sequence is that the first point of difference is 4 and 5. It's lower if we start with the carbon being the first one on the left. Now, how does this change if we have a cyclic compound? So we've got 3 cyclic ones here to help you with it. The first thing we have to ask with the cyclic compounds is the carbon ring have more carbons or less carbons than the branches coming off of it? So if we look at number 3, we've got 1, 2, 3, 4, 5, 6 carbons versus the branch, which is 1, 2, 3, 4, 5. So if the ring has more carbons than the chain attached to it, the ring is the parent chain. So for number 3, this would be cyclohexane as the parent chain. Now if we come to the one beneath it, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 carbons in the chain versus 1, 2, 3, 4, 5. So in the case of the 5, this ring isn't going to end up being a branch off the chain, and we would start with decane for compound 5. So for number 3, we've got cyclohexane. If we've only got one thing on it, we don't need to specify the position because it is there, but we're going to name the branch based on the number. So it's going to be, here's 5, meth, F, but, pro, pent, and we're going to put a YL here. So the pentyl here, the YL tells you that it's a branch. So when we looked at examples 1 and 2, we had ethyl and we had methyl. The YL tells you that it's a branch off whatever the parent chain is, so we would just call this pentyl cyclohexane. Now for example 5, our parent chain is decane, and we've got 2 groups. We've got a methyl group, and we've got a cyclopentane. So cyclopentyl. because pentyl comes after M, this is going to be, so we need a number for the methyl position, and we need a number for the cyclopentyl. Now, again, if this was just a 5-member arene, we call this cyclopentane, but because it's a branch, we add that YL to indicate that it is an alkyl branch. Now, since the methyl group comes first, we want to memorize its numbering, so this is going to be 2-methyl, 3, 4, 5, 6, 7, cyclopentyl decane. So the approach with this, again, identify if it's linear, if it's a linear branched alkane, or if it has a cyclic, if it has cyclic compounds. If it's the cycle is bigger than the rest of the carbon chains, the cycle is the parent chain. If the cycle is smaller than the linear chain is the parent. Go through, name all the branches off the parent, and then look at that ordering and try to figure out how to minimize the number of the first group that's on there. And if you can go from either end of the parent chain and get the same starting number, start looking for differences. So if we get to like the cyclopentyl, is there a different way we can order to reduce this number while keeping this as a 2, and so forth. So that's how you approach naming alkanes in a nutshell. Answer your question? Yeah, and that's what the practice packets are for. Honestly, it's a very utilitarian way of naming it. Even if you name it wrong, you can still reverse engineer what the correct answer is based off of how you named it wrong. So this is kind of the joy of the IUPAC system. Is very much based, it's a very German way of naming it. Again, because it's very like rule based. You start with the right and work your way to the left. And particularly when we start getting to things that are chiral. So if you have an R or an S configuration, the only thing you would add after you do all of that, you just name the compound as is. Then to designate R versus S, that just goes on the left. If you have more than one chiral center, you'll designate what the number on those chiral centers are. And you saw that with kind of the earlier practice packets when we talked about chirality, like the 2R, the 3S. Start on the right with the parent chain, find the branches, number the branches, include chiralities, especially if you have like cis-trans and things like that, which we'll be talking about next week. It's very straightforward, but you just have to remember with this, you're going to work right to left when you do the naming. And the same thing's going to be true when you draw the compounds. Work right to left. It tells you what the parent chain is on the far right, so write that out. Then pick an arbitrary starting carbon, and you know where each of those branches are coming off the parent chain based off their numbers. Any other questions out there? You're welcome. Still got 2 other lurkers. Yeah, my cat likes to interrupt the live streams as well. Just know if I start grading, I'm only going to get a whole bunch of questions, so let's tempt fate. Just a minute. All right, so not looking like there's a lot of questions today. In fact, there have been in for the past 45 minutes. So live stream tomorrow. I'm guessing a lot of y'all don't have questions right now because we have just started the new test 2 material. But again, if you ever have questions, you can always email them out in advance, and I will try to answer them at the start of the next live stream. So thanks to the few of you that were able to make it out today, and I will see you all tomorrow and next week.